Good morning again. In the last class, we were looking at this program. It's a multi-file program. So close this one. Yeah. So let's close this. So we are looking at this program where we have main.c. So let me remove this thing. So in main, uh, so we call three functions. Sort read names function on line 36, and sort names function on line 40, and print names function on line 48. And this program takes command line arguments. It takes the name of the file that needs to be sorted as a command line argument, and it prints the sorted file in another file with dot sorted added to the source file. I hope all of you got a chance to look at this code because we have been using this code, this sequence of codes for the past 4-5 lectures. I hope all of you are on the same page with me here. Otherwise, no, today we will do more modifications to this program and you will get lost. I hope you are able to see. And in the helper function, so we have three, in the helper function, so we have three functions in the helper.c file. You have read names function, and you have print names function, and we have swap and sort names function. So, and both the main.c and helper.c, they include this header.h file. So let's see what is there in the header.h file. In the header.h file, it contains the prototypes for the three functions: read names, print names, sort names, and then some macros which are used in the program. So ideally speaking, if you think about it, these macros are not useful. These macros are not useful for main.c. They are primarily useful only in helper.c. We might as well write the code like this. We can just put these macros in helper.c, and main.c still works because in main.c we are not using those macros. It is the header files actually can contain helper function definitions also. So there's nothing which prevents us from writing function. Any valid chunk of C code can be present in the header.h file. From the preprocessor perspective, when it sees header.h, these three lines of code will be replaced by. I will show the make file for in a moment frame. So it is quite possible it depends on the use case. Sometimes you want to put function definitions in .h files also, but by and large we prevent that. By and large we prevent it. Yeah, so for all practical purposes, this hash include header.h is like a text file substitution. That's all. It doesn't know anything, nothing else it does. That's true, very much true. Now let's compile this program and see what happens. So this is GCC. What do we do? Main.c helper.c, and you don't need to give helper.h file as the command line. It's not necessary. Okay, and then .a .out names.text, and then that names.text, the sorted names are present in names.text.sorted. So this is the file name in which it will be present. So this is the story, and there are a couple of things I would like you to, one important thing. So yeah, let's look at helper.c file. You know that the read names function, all these function names, these functions by default, their scope is the whole program. That is, they are visible to the code that is written in other files. Like for example, main.c is able to call read names function by default. There is no, we don't need to use header.h in the command line. No, not at all. That's what I'm mentioning. So, and so similarly, print names is also by default visible, swap is also visible, sort names is also visible, but we know that swap is something internal. Okay, so we don't want swap to be visible to main.c because swap is a helper function for the sort names. Sort names use swap on line number 71. So main doesn't need to know anything about swap. So we just put a static keyword against the function swap. So swap is not visible for the main. So from main, if you call swap now, then you will get an error that no, it doesn't know what the swap function is. Right? So this is the right way to do it. I want you to understand this. By putting the static keyword here, we are confining the scope of the function swap to this file, which is helper.c. Are you with me here on the use of static for the keyword? Yeah, we can no longer call swap from main.c. That's true. And so there is this question. So yeah, let's do one thing. So if you want to, if you are interested, so just want to, I would like to say, we can even have this header.c, but you will get an error. There is no, not header.c, helper.c. So you can have helper.c, but you will see that there will be compilation problems. Can anyone guess why there will be a compilation problem? Right now, that it is not showing. No, there is no two mains. Helper.c doesn't have any main. Please notice. Helper.c doesn't have any main. But the problem is header.h is included twice. So this prototype will be included. You will get two times. And because of that, when you compile, I think you may get, yeah, you will see multiple definitions of read names. And so are you with me here? So in order to solve this problem, so people do one thing, hash if not def some variable, okay, header underscore h, you will say hash define header underscore h, and if. So what happens is when header.h is included for the first time, then at header underscore h macro will be declared, will be defined. And when it is included for the second time, this code will not be included twice. Are you with me here? Do you see what is going on here? How many of you are with me? Let's try to compile this code and see. Still, hash include header.h. helper.c. Oh, just GCC main.c. Okay, okay. Okay, got it. Thank you. There is, in terms of include, there is no difference between including .c and .h. How many of you are with me here on what we did so far? There are only 81 students. There are 110 students. Yeah, so you should be careful. So see, what is happening is this. Okay, so let me explain what's going on here. So when we are including in main, let's say the program. So we compile this code using GCC main.h. This is what we did. GCC main.c. This is what we did. So when we did GCC main.c on line number 5, header.h is included. So when header.h is included, when the preprocessor tries to process this, it checks if header underscore h macro is defined. It is not defined because it is the CPP is hitting that statement for the first time. And so because of this, line number 2 to 5 will be included in the code. Are you with me here on this one? So this line number 2 to 5, this line number 2 to 5. So what happens is this whole thing, no, this header dot h, when because of the header dot h, so the line number 5, it will be replaced with lines 8 to 13. And so CPP checks if header underscore h is defined. It's not defined. So now it is defined. And not only that, the next 3 statements will also be included. That is the effect of including header.h file on line number 5. Header.h is, it can be any macro. It can be any macro it can be header. We are just using header underscore h to indicate that we are trying to deal with header underscore dot h, but it can be any macro. It's perfectly fine. So now it doesn't matter. Now what happens is, so now we include helper.c. When we include helper.c, all these things are included, and then header.h is also included. But when header.h is included, what happens is, the macro, this is defined because of that, no, lines 9 to 12 will not be included for the second time. We are defining header underscore h on line 9. Are you all with me here? Can you? No, this is like a meaningful name that we are trying to work with, and header.h file. It can be anything. It still works. We just want to use a macro to not to include the header.h for the second time. Yeah, that's true. If if header underscore h is defined, means it's, yeah, still works now. There's no significance to header underscore h. It's just a macro. So let's get it back to header underscore h. So this is how. Are you all with me on this example? So now one important thing here is the particular way in which we are doing here is, in the previous case, we have main.o, helper.o, and we link them together. Now there is no helper.o. The source code of helper.c is included in the main.c. So it will not be compiled separately. There is no separate compilation for helper.c. I want you to all to understand this. In this particular approach, there is no separate compilation for helper.c. Do you understand? Are you with me here? because we are just taking the whole code and keeping it in main.c through this include function. Great. So now, if you are with me on this one, I would like to go back to the previous code because that is a cleaner thing. So let's, but I'll let it be like this. Yeah, so what I'm trying to tell here is in the previous version, in the current version, there is only one source file. Helper.c is included in this main.c. But earlier, we are using this gcc main.c and helper.c. In the last class, we have seen implicitly main.c gets compiled to main.o, and this gets compiled to helper.o, and both of them will be linked to generate a dot dot. But now there is nothing like that. There is only main dot. There is, see, helper.c disappears. In this particular case, after helper.c code is included on line number 16, helper.c doesn't have any kind of role it plays beyond that. Yeah, that's true. The preprocessor replaces helper.c with all the source code, and we no longer need to compile helper.c. That's true. It is equivalent to copying everything in helper.c and pasting it in main.c. There is no declaration for helper.c through. Okay. You want to see header.h. So if helper.c is in another, or any of the include files are in another path, so we have to use a path. Kush, we never used header.h. Kush, it's clarified before also by me and someone else also. I think you missed it. So we don't use header.h at the compilation. Okay. So Pramod has an interesting question. What if there is a bug? Yeah, let's create a bug here. The question is, if there is a bug in helper.c, how will it be reflected? Yeah, you can see, yeah, in file included from main.c, helper.c on a particular line, there is an error. Does it make sense now? I think this answers the good question from Pramod. Good, good. So we are in good shape now. So one more thing I would like to tell here, there is this question. Let's say the include files are in, I have a directory called include, and in that I am moving header.h to include. Okay, so now I want to change the code back to the original stuff. Okay, so it says now it is deleted main.c. I don't want to include helper.c. Now we are going back to the original code where we are including only header.h and helper.c is contains contains the helper functions, and the only difference now is our header file is present in a directory called as header.h. So what do we do? So now when I compile this thing main.c and helper.c, there is a compilation problem that header.h is not found. So there are a couple of ways of taking care of this. Maybe I can use this, and maybe I can give the full path of this. I don't know whether, let's see if it works. Yeah, I don't think this is the right way to give this one, because dot is something which the bash knows, but oh, dot include. Huh? Oh, okay, dot include. now it is done. But this is not a nice way to do stuff. So what do we do? So an alternate way to do it is GCC minus I. I stands for the include path. Include main.c helper.c. So now you can give the include paths using the minus I include variable, and it gets taken care of. So you're all good so far? Minus I basically gives the include, the place where it should be looking for header.h. The header.h file, that include file, is present in the include directory. It is present in the include, it is present in the include directory. So what we are giving is we have to use, it has to be capital. So we are telling the compiler, please look for include files in this place, in the directory /include. It has to be capital, like minus I flag has to be capital. That's true. By default, GCC uses the standard path for the include files. That's true. There is a default include file path. If we copy our include files in that path, then it's not necessary. It looks at the current directory and it looks at the include directory that is specified also. I think you got the big picture. Let's not get into the details. I want you to explore the details by yourself in interest of time. Is it all right? Shall we move ahead? We will take a look at the Makefile. Okay. So I want to move ahead because include is in the current directory. This is, no, I don't think so. There's no way to make something visible to one file. Maybe you can, using Makefiles, you can do, like for example, you can use minus I include one for main.c, minus I for helper.c. All right. So now the next idea is, let me move my header.h2, mv include header.h2 this minus rm minus rf include. So this is what we have. So here, if you see right now, one thing that I would like you to understand. So every time, so how do we compile this code? GCC minus o my sort and main.c and helper.c. This is how we are compiling this. Oh, okay. This is how we are compiling. So the thing here is this. Right now you have two small programs. Main.c is a small, it's a small, it contains few lines of code, and helper.c is few lines of code. But let's say you are working on Linux kernel, which contains some 1,000 files. And you are working with one small function in one particular file. So if you make a small modification to that particular function, which is present in that particular file, then you end up compiling, like all the files. No, we don't manually type all the files. Okay, that is one. So, let's say there is a file 1.c, file 2.c, so on and so forth, file 1,000.c. And so we already have seen, so file 1.o, file 2.o, so on and so forth. So file 1,000.o. and all these files, they will be linked to generate, let's say, Linux kernel. So what happens is, if you kind of make modification to, let's say, this file 1000, then in order to create this Linux kernel, then you have to uh, yeah. So the whole thing becomes no. You have to compile each of these files, and you have to do the whole linking process. So as Pratyaksh rightly pointed out, compilation itself is not a big problem. Maybe possibly you can use gcc star.c. Uh, so and then you use minus o Linux kernel, maybe something like this may happen. So that is a kind of some uh, so this is one way of compilation. Compiling command itself is not a problem. It is also a problem, but let's say it is less of a problem. But there is a second problem, that is, even if you make a small modification, let's say you forgot to include the semicolon in one particular statement in file 1000.c, then you end up compiling all the files, linking them, and it could take an hour. So this becomes a real challenge if you are working on big software. Let's say if you are working on Chrome browser. So if you're working on Chrome browser, the whole source code could be present in 1000 files, and you are working on one small feature somewhere, and you make some small modification, and the whole thing needs to be recompiled and linked, and the compilation time will be very large, like it can go to an hour easily. So in order to solve this problem, Makefiles is a nice way to solve this problem, wherein what we do is we kind of the Makefile figures out that only file 1000.c got modified. So all it needs to do is, it just needs to compile no this it just needs to do this part, and then of course this part also, because this file has changed, so the whole linking process has to happen again. So let's see how this works by looking at the Makefiles. Let's go to, so this is I have written a Makefile before. So we can use some flag variables in the Makefiles. Like for example, on line 6, we are saying that the compiler that we are using is GCC compiler. And on line 7, we are all the flags that we would like to use during compilation, we are using that. And here in the Makefile, there will be multiple targets. Uh, so the target here is, like for example, in order to generate my sort uh, target, you need main.o and helper.o. So in order to generate my sort, this is executable. You need two files. One is main.o and other is helper.o. Are you with me here? I want you to pay attention. No, don't. No, we are just trying to tell this what is called as a compilation process. It's any variable that we are using. Cflags is a variable that we are declaring. Makefile is just a some. It's a kind of a language which the make command understands. There is what is called as a make command. You will see that commands understands this. You will understand. Please be with me. There is this Makefile which we write using certain syntactic convention. I want you to, yeah. So take a pause and please follow me. This is a language, this is a very small language which we have, which is there, which the make command can understand. Or make is one program, okay? So here what happens is, so on line 12, we are telling the make program that in order to uh, have create the mysort target, it requires two object files, main.o and helper.o. And so once it has main.o and helper.o, it uses this particular command to generate mysort. So wherever $cc is there, it gets replaced with gcc because we have defined cc to be gcc. And wherever $c flags is there, it gets replaced by the c flags that we have given here. So in order to create this target mysort, so this is what we do. Okay, we are telling two things. Number one, that main.o, it requires main.o and helper.o. And how do we create, what is the recipe for creating main.o? So this is the target and these are the ingredients and this is the process. So we use this process. What is the process? This is the command. This command tells you how to use main.o and helper.o to generate mysort. Are you with me on this one? Mysort is what we want to cook. And what are the ingredients for mysort? Main.o and helper.o. And what is the exact recipe to create mysort from main.o and helper.o? This is a particular command. This is a recipe. Yeah, this GCC automatically links it to other recipes, so other libraries. What is the function of C flags? It's just what are the flags you would like to use to compile your program, that's all. Nothing happens, mysorts get created and you can execute it. No, mysort is an executable. Don't worry about pedantic is one option, one command line option, which kind of gives a detailed information about. Yeah, so let's go on here. Yeah, so I have to maybe clear this thing. It's like this, guys. So if you want to know, mysort can be paneer butter masala, and what are the ingredients for paneer butter masala? So paneer and butter and masala. And so if you, it's like make paneer butter masala. So you go look for paneer, you go look for butter, you go look for masala. And the question, what happens to mysort? Now, what do you do after making paneer butter masala? You eat, na? So you execute here. And so so that's what happens. So what happens after make? So mysort is created. So this is main.c. uh, using the first line, main.o got created, helper.o got created, and mysort dot created. And now you just use mysort. What do you do with mysort? That's the question. It's an executable. So mysort names.txt, great, it worked. Great. So now please pay attention. Now you got some idea. I want you to take a pause. So main mysort depends on main.o and helper.o, and main.o depends on two. So there are two ingredients for main.o. One is main.c, other is header.h. See, you have to be patient, and because I'm getting to the questions you're asking. So helper.o, it requires two ingredients. One is header.h and other is header.c. No, helper.c. This is what is called as a dependency graph, helper.c. So this is the whole dependency graph. So what happens is, let's say you change the helper function. Let's say you change the helper function. If helper.c changes, then what all the things that will change? If helper.c changes, what all the things that will change? If helper.c changes, then helper.o will change and my sort will change. So what happens is the make file, it doesn't compile, it doesn't generate main.o because it is already there. So we don't recompile main.c. On the contrary, let's say if main.c changes, then main.o will be affected. Because of that, my sort will also be affected. So only no, this main.c will be compiled. Are you with me here? Are you all with me? And if header.h changes, then helper.o also changes and main.o also changes. So because of that, both compilation will happen. So how does Makefile know what changed? I think based on it uses some timestamp to figure that out. Date modified. Yeah, that's true. So now let's use this so let's play. Let's go here and see what will happen if I do a make. What will happen if I do a make? What all the things that will be compiled? What will happen if I do a make? Nothing happens because .o files are already created. And the main.c helper.c didn't change. So it says it is my sort is up to date. We don't need to do anything. See, we already compiled the program and my sort got generated. And after the generation, main.c, header.h and helper.c, they didn't change. That's true. The executable MySort got generated more recently than main.c and header.h and helper.c. So because of that, it's not necessary for the Makefile to do any compilation. Are you with me here? So now let's do one thing. Let me remove helper.o. I remove. What will happen if I do a make? Only helper.c will be compiled. Only helper.c will be compiled to create helper.o. Now you can see only helper.c got compiled and to generate my sort. Understood? Are you with me? Now I do a make, it says up to date. We will go to the clean first. Are you with me? So are you able to follow the... No, make command is not C language specific. It can do a bunch of things. It is, we can compile C++, Java, many things using make. You just check now. Pedantic means generate errors in a very nice fashion so that you understand what is happening. Vikram has this question: do we need to follow the hierarchy in writing the make file? Yeah. Let's see. I think it will work nonetheless, but we have to give the target specifically. If we just do give the make, then what happens is the first target will be taken as the default target. It will work, but so now I have one more thing. Make file. Let's go to header.h. In header.h, I am just changing this and then putting this back again. So now the timestamp on it is changed. So now what happens when I do a make? I change it header.h. What happens when we do a make now? What happens? Main dot because main.o helper.o they depend on header.h, so both will be compiled. Look at the diagram. There is a reason I kept this diagram here as we are doing this. Header.h got changed. Since header.h got changed, so we have to recompile this. Okay, this we have to recompile, this we have, and this is what is happening. Are you all with me here? Of course, it is dependent. Main.c is no. Main.o is that's true. The linker gets activated only at this point. The linker gets activated only at this point, not at this point. No linker here. Yeah, that's true. And header.h file gets changed, everything gets recompiled because we are including header.h in both this main.c and helper.c. -c makes main.o object file. That's true. So one thing that you should do is going forward from now onwards, you should use only you should use Makefiles to build your programs. I see students even after coming to second year, third year, also not using Makefiles. So Makefiles is essential. And there are many things about Makefiles. I just give an introduction to it. So I think you have many questions. So they are all valid questions. But we will not be having a tutorial on Makefile here. But the most important ideas in the Makefile I have introduced here. -c we have discussed in the last class, Vikram. It generates an object file. It doesn't link it to the no standard libraries will be created. It will not be linked with standard library or anything like that. Only object file will be created. Object file, what is an object file? The object file contains the opcodes, the machine encoding of the instructions corresponding to different functions that are present in that .c file. So regarding the discussion on .o in the last class, we had good discussion, I guess. Please review it once. I didn't post the last lecture's recording. There is some .gch file. I don't know what .gch file means. Yeah, I also don't know. Header. GCC precompiled header for C. Yeah? Okay. Not sure what happened. Yes. Yeah, so finally we have to do one more thing. So we have to do, so usually what we do is after we compile, so we do a make clean. So the target for make clean is remove all .o files. You just search Makefile, there are tons of things that you get online. So shell script is a language which the bash understands, and Makefile is a language which your make command understands. See, just like C and Python, these are all different. When we just do a make, what happens is it will pick up the first target by default. The first target is my sort, and that will be picked up. And in order to build that my sort, it will do everything. It doesn't do clean automatically. No. When we just do a make, clean will not be. The first target my sort will be picked up, and in order to do build my sort, everything that is required, the make file will do. I don't think clean is a reserved word. I think it can be anything else also. It can be clean one also. I don't think. Yeah. So make file is a, like there are instead of make file, if you have something like cp make file my make, you can also say make my make. Sorry, make my make. So that's true. So Kishore has the thing. So it by default it checks for capital Makefile and then small Makefile, and then you can give specify a file name also as this is my Makefile, etc. That's true. Clean will not be executed unless specified. All right. Are you all with me here today? So far, I'm seeing there are only 86 students in today's lecture. You're all. No. Uh, my make see Rohan, it's just that you can have your own by default, as Kishore mentioned, that by default it make looks for make file these files in the current directory, but we can override all these things by giving make my make file. This can be anything. It can be my make, or you can just even say random dot mk. Like for example, I can say cp makefile to random.mk, and then I can say make random.mk. Oh, okay. I think maybe I got this wrong. I think I have to use make minus f. Yeah. Yeah, minus f. See, one thing I want to make it clear, since we are about to come to the end of the course. So what's the moral of the whole course? The moral of the whole course is learn, see, no, explore new things, read man pages. Yeah, the moral of the debug till you cry, finally shift to C++. Array, that is depressing frame. After studying C for the whole semester, you want to say that we want to move to C++. The moral of the story, personally for me, is a faculty doesn't know everything. So you ask a question, no, so I don't know the answer. Sometimes I know, most of the times I don't know. So by the end of this course, I exhausted whatever I know. So if you ask me something, I also have to learn it by reading man pages or reading the textbook or looking at up some resources. And that's what you have to learn, how to learn. That is what you should. So you should learn how to learn. So otherwise, no, it's not like everything will be told to you. Makefile, yeah. So you ask me 100 questions. All the things that I know about Makefile, I already told in 5-10 minutes. And if you ask me anything more, so I don't know. So I also have to check. So, so that's all. So we will, and we have to learn to figure out how to learn. Yeah, so that's what I want you to understand since we are coming towards the end of the course. So please do understand that that's important. So that's enough of, it's not philosophy actually, it's an essential thing. You don't, I hope within no short period of time, you know way more than me. And if I have any questions, I'll come to you and ask. And it's already the case. So